So we are going to define today the idea of infinite products. You have seen the concept of infinite sums. This is infinite series. Infinite series is formed by taking the infinite sum of numbers, whether they are real or complex, and you know all the how it converges. If the sequence of partial sums of this given series is convergent, then we say that the series is convergent. And now instead of taking infinite sums, we are going to take infinite products. And then we have to define their convergence as well. Infinite product and infinite product, we are going to use the expression, we are going to use the notation for infinite product. Uh, this is the expression for the infinite product. This is the notation for infinite product. ये जैसे summation है तो ये product का notation है simple. So where we are taking each pj to be a complex number, and then we say that this infinite product is convergent if the first thing that must hold is that the limit of these numbers, this sequence of numbers, as j tends to infinity, must be 1, or you can say as that, anyways. And the second thing is that since these are the complex numbers, what I have to do, I have to take the principal log of each complex number and I have to sum them, and then we get a series by taking the log of each p, each term or each factor. This pj is called factor of the infinite product. So we have to take the principal log of each factor and then sum them. And if this series is found to be convergent, then we say that the infinite product is convergent. So these are the two conditions required for an infinite product to be convergent. But we have to be very careful here, because if any one of pj is 0, then your log will not be defined. It is undefined. So what we are going to, where let me write, we sum only over the terms for which pj is not equal to 0. For the pj equal to 0, we do not consider that to be part of this sum. So this is a definition for an infinite product of numbers, whether they are complex or real numbers, to be convergent. The first requirement is that the limit of this sequence of which we are forming the product has to be 1, and then the corresponding series found by taking the principal log of each number has to be convergent, and you have to be careful that we have to sum over all those pj's which are non-zero, because at 0 log is not defined. So there are some let us first fix how that the limit of an infinite product. So suppose if this infinite product is convergent, then there are two possibilities of the limit. Then we define its value to be 0 if one of the pj is 0. बी केयरफुल, ये हम इसकी वैल्यू जीरो डिफाइन तब कर रहे हैं जब ये कन्वर्जेंट है। अगर ये कन्वर्जेंट नहीं है तो देन, और कन्वर्जेंट प्रोडक्ट नहीं है और उसमें कुछ वैल्यूज जीरो हैं, तो then we cannot define its value to be zero. The value of infinite product is zero provided first the product needs to be convergent, और convergence की definition से वो convergent होना चाहिए. Then we define its value to be zero if any one of the factor in this product is zero. Otherwise अगर कोई भी factor non zero, कोई factor zero नहीं है तो then otherwise we define its value, we define it to be एक्सपोनेंशियल ऑफ जो इन्फिनाइट सीरीज हमने फॉर्म करनी होती है बाय टेकिंग द इन प्रिंसिपल लॉग ऑफ ईच टर्म, we have to exponentiate that series and then that will be defined to be the value of this infinite product. ठीक है जी, तो ये आपको याद रखना है कि जीरो कब होगी, कन्वर्जेंट प्रोडक्ट की वैल्यू जीरो कब होगी, जब एक भी वैल्यू उसकी, एक भी फैक्टर उसका जीरो होगा, अदरवाइज इसका जो लिमिट होगा दैट विल बी इक्वल टू दिस थिंग, इट्स वैल्यू विल बी दी कन्वर्जेंट सीरीज होगी, क्योंकि ये सीरीज भी कन्वर्जेंट होगी आपके पास, दिस विल बी कन्वर्जेंट इफ योर प्रोडक्ट इज कन्वर्जेंट, देन एक्सपोनेंशियल ऑफ दिस विल बी अ फाइनाइट कॉम्प्लेक्स नंबर, then exponential of that will be also a finite complex number. So this is definition and its limit. Now let us have some observations. The first thing is that if this product Pj is convergent, then at most finitely many Pj's can be zero. ठीक है जी, तो ओनली फाइनाइटली मेनी पीजेस कैन बी जीरो इन अ कन्वर्जेंट प्रोडक्ट, दैट मीन्स अगर आपके पास ऐसा प्रोडक्ट है जिसमें आपके पास इनफाइनाइटली मेनी वैल्यू जीरो हैं, तो दैट प्रोडक्ट हैज़ टू बी डाइवर्जेंट. ठीक है, व्हाई दिस इज सो, why this is so, because you see when you say that um, their project is this product is convergent, then that means that the sequence of these pj's converges to 1 as j tends to infinity. So what it means, if we choose, then by using the definition of the limit, then for some epsilon equals to, let's take epsilon to be 1, there exists some number k depending upon epsilon. I'm using the definition of the limit such that the mod of pj minus 1 is less than epsilon, epsilon is equal to 1 for all j greater than or equal to this k. So what it means, you have this situation, you are taking 1 as a center, and then let me draw a disk of radius 1, then this inequality, pj mod of pj minus 1 less than 1 implies that this is a disk with center 1 and I'm taking its radius to be 1. This says that each pj is an element in this disk, and you see this is an open disk and this disk doesn't contain 0. This disk doesn't contain 0. That is to say that pj is not equal to 0 for all j greater than or equal to k. So the only value of 0 of the which pj's can be possibly 0, then these are thus if there is any pj equal to 0, then it must be from p1, p2, so on up to pk minus 1, and these are finitely many. So at most, there are finitely many pj's which are 0 when the product is convergent. Is it okay? Is it clear? आवाज आ रही है ना? Okay. So the second observation is that if you have infinite product, and if this infinite product is convergent, if this infinite product is convergent, then the value of this infinite product can be computed as a limit of some sequence, and it can be computed as a limit of these j from 1 to m, and taking limit m tends to infinity. That is the product of these first m terms. Okay, so we can call this as a, just to match or just to have an analogy with the series. We call it as, we can call it as partial product, the way we call partial sums of a series. So it says that the sequence of partial products, then you are going to this get a sequence of partial products. If I denote it by Tm, that means to say that this value of this infinite product, if this product is convergent, is nothing but is the value of this limit of this sequence. Is it okay? So let's verify this thing. Let's try to see. But be careful if the product is convergent. Let me first note that uh, if the value of pj is 0, obviously p value of pj will be 0, then at least some pj is 0, then and then you then mm, there is some k greater than 0 such that pk is equal to 0. There will be some factor which is 0, and so then the product j from 1 to m pj is equal to 0 for all m greater than or equal to k. So all these products are 0, and hence the limit of these sequences will be also 0. And so then limit m tends to 0, and j from 1 to m pj will be 0, which is equal to the value of the product. So this is the situation when you have the value of the product 0. So now let's assume that the value of the product is non-zero. That means that will imply that each factor in this infinite product is non-zero. So suppose that the value of the product is non-zero, then how do we define its value? Then its value is defined as exponential of, वो राजकोट सर ऊपर होंगे, this is exponential of summation log of pj. This is way how we define this is something that I said you already. This is way how we define the value of a non-zero infinite product. And now when this product is convergent, then you know that this series is convergent, and when once this series is convergent, this series can be, this series is the limit of its partial sums. This has to be limit m goes to infinity log of pj. Okay, and now I'm having this exponential outside and limit inside, and since you know that exponential function is continuous, and we can then that will imply the interchange of limit from inside to the outside, since exponential function is continuous, so that means that exponential of limit summation j from 1 to m log of pj has to be limit m to infinity exponential of summation j from 1 to m log pj. And now using the property of the exponential function, I can write it as limit m tends to infinity. It is exponential of, it is the product because sum gets converted into the product in the form of exponential. Now you have this inequality now, e of w1 plus w2 has to be e of w1 into e of w2. I'm using this identity of exponential function, so it is exponential of log of pj, and now exponential and log are inverse to each other, so this is limit m tends to infinity. You are left with this is j from 1 to m, and the range for is from j from 1 to m, and it is p of j as desired. This was the desired equality. Is it okay? So simply by using the definition of convergence and these two observations, you can verify the following other two observations, that we can always factor out a finite number of terms from a convergent infinite product, from a convergent infinite product. That is to say, that is, if you have an infinite product j from 1 to infinity pj, you can factor out some finite number of terms p1, p2, so on up to some pn, and you can write it in this way: j from n plus 1 to infinity p of j. This is always possibility. This can be done. And the other thing, another observation is that if this product pj, this is an infinite product, is convergent and no pj is equal to 0, that means every pj is non-zero, that is to say that pj's are non-zero, then the value of the product cannot be 0. Value of this cannot be 0. We have to be very careful. So these are the following observations that you need to keep in mind, and that these are immediate consequences of the definition of the convergence of the infinite product. So before moving on, let's see an example which might help us to get a better insight of this convergence of infinite products. So I'm considering this infinite product k from 1 to infinity, and I'm having pj as 1 plus minus 1 k plus 1 upon k. If you write it in expanded form, you see the first term for k equals to 1 is 1 plus 1. Then substituting k equals to 2, you're going to get 1 minus 1 by 2. Then you're going to get 1 plus 1 upon 3. Then 1 minus 1 by 4, and so on. Okay, now let us have some observation first. Look at this. If I take this product 1 plus 1 upon 2 to power k minus 1, I have taken in denominator 2k minus 1, which is odd number, and if I take its power to be 2k minus 1 plus 1, that will be even power, so I have only 1. And now if I take 1 plus 1 upon 2k, but then I have to take this to be minus, because this has to be minus. Okay, look at this product. Look at this product. What value you are going to get? You're going to get, this is, if you simplify the first expression, it is 2k minus 1 plus 1 upon 2k minus 1 product with 2k minus 1 upon 2k, this is equal to 1. So when we are going to form the partial products, so hence this value j from 1 to m, 1, let me take it to be k, from 1 to m, 1 plus minus 1 to power k plus 1 upon k. This is going to take two kind of values. The first, when you take m to be this m to be even, and you see when m is even, you can pair out these factors, and then each pair is going to give you the value equal to 1 when m equals to even, and then this is going to be 1 if m is even. And now when an m is an odd number, then there will be a one factor which cannot be paired with any other factor, and that will be the last factor, and the last factor is going to be 1 minus, because m, then you are going to take m to be even odd number, and m plus 1 will be even, so minus 1 to power m plus 1 is going to be 1, then you are going to 1 plus 1 upon m if m is odd. And now you can see, this implies that the limit or the value of this product as k ranges from 1 to infinity, 1 plus minus 1 to power k plus 1 upon k. You take the limit m tends to infinity, you see it's going to be get equal to 1. Is it okay? Is it clear?
Yes, sir.
So this limit is 1. That means this infinite product is convergent, and it converges to the value equals to 1. Okay. So, but we are going to make some changes in writing. It has to be remembered as a remark that it is convenient to write each pj as 1 plus aj. I can write any number as pj equals to 1 plus some other number. That's not an easy way, but the simplest way to do is that you just write pj equals to 1 plus pj minus 1. That hardly matters. Then this will be work as aj. So this is the way I can put this expression as way. And if I write each pj as 1 plus aj, and then the infinite product, then the infinite product can be expressed as, then the expression, then the infinite product uh, can be expressed as j from 1 to infinity 1 plus aj. This is always true, and we are going to get into this notation only. And so then note that if this infinite product is convergent, अगर इस फॉर्म में आप इसको लिखते हैं, if this is convergent, तो कन्वर्जेंस की डेफिनेशन होती है कि pj must converge to 1 and when pj converges to 1 then aj will converge to 0, then aj will go to 0. And in convergent infinite product we had seen that only finitely many pj's are 0. And you see pj is equal to 0 means aj equals to -1, and so we can say that only finitely many aj's are equal to 1 -1. But another thing that we have to keep in mind is that for most purposes we can ignore the terms for which 1 plus aj is equal to 0, because that's a thing that will always bother, that will always trouble you, because and that will give the value of product to be 0. And we cannot check the convergence with 1 plus aj equal to 0. We have to check the convergence with the product in which you don't have the zeros, for which aj is equal to 0. And then we will work with the something that is remain to us, and that the only thing that will remain to us is a tail of this product, and work with the tail. You see, tail is something you have to draw finite, first finite terms, and then after that what is left to you is a tail. So I have to drop every term. I have to take the maximum j for which 1 plus aj is 0, and I have to drop everything before that, and what will be left to us is a tail. And then we will check this infinite product, and obviously we see when once this product is 0, you see, once this product is convergent, if it is convergent, then as seen aj converges to 0. So we can say we can say that aj converging to 0 means it will be always in a neighborhood of 0. So we say that in this tail aj is always near to 0. So this is something which we have to keep in mind. And the first thing that we are going to observe is the following result regarding the convergence of infinite products of non-negative numbers. I'm considering non-negative numbers tj's, and in case of non-negative numbers, the infinite product 1 plus tj converges if and only if this series of tj's converges. So this is a beautiful relation between the convergence. The convergence of infinite product is equivalent to the convergence of this infinite series, but provided each tj is positive number, or that we can say that each factor is greater than or equal to 1, because tj is greater than or equal to 0 means 1 plus tj is greater than or equal to 1. So now we have this following observation. So note that first thing, the first thing you observe is that whether this infinite product converges, whether 1 plus tj converges, or the infinite series converges. In both the situations, or in both the cases, what we are going to get, the value of tj will tend to 0 as j tends to infinity. This is the necessary condition of convergence. अगर infinite product converge करेगा तो 1 plus tj 1 को converge करेगा, that is 1 tj will converge to 0, and series की necessary condition है convergence की कि उसकी nth term 0 को converge करती है. So what we are going to do, we can, क्योंकि tj is always near to 0, तो so without loss of generality without loss of generality, we may assume, क्योंकि t is always near to 0, it is quite in a neighborhood of 0, we may assume that uh, each tj lies between the interval 0 and 1. And this is it. Now we have an observation that you need to, there is an estimate. We know this estimate that you can verify that for any value of t which is greater than 0 and less than or equal to 1, we have t half is less than or equal to log of 1 plus t. You might have done this in your calculus or real analysis course, such type of estimates. We have always this thing. So for t is equal to 0, this holds also, because t substitute करो तो throughout आपके पास equality हो जाएगी. So yeah, you can assume t to be greater than 0, all that hardly matters. T equal to 0 को you आप drop भी कर सकते हैं, ठीक है. Now you see, if we take, instead of tj, if we take j, instead of t आप tj ले लेते हैं, the factors, the terms of the infinite series and the infinite product. So for j, you can write tj upon 2b less than or equal to log of 1 plus tj is less than or equal to tj. And if you remember the comparison test from the infinite series, then you see the infinite series corresponding to this term tj upon 2 will be convergent if the infinite series corresponding to the terms log 1 plus 1 by 1 plus this. Let me write the two series first. It is log 1 plus tj, इसके corresponding series आएगी. इसके corresponding tj, I can write 1 by 2 outside. It has to be summation tj, and इसके corresponding the series that is simply summation tj. And now you see a comparison test. What comparison test gives you? If you look at this part first, then since each term of this summation tj is the dominating term of the series summation log of 1 plus tj, then the convergence of this summation tj will imply the convergence of this series 1 plus tj. And further, so this was the right part of this inequality. Now let us look at the left half of this inequality. And in case of left half of this inequality, this part, you see the convergence of this log t, because the dominating terms are from this series summation log 1 plus tj, then the convergence of this will imply the convergence of 1 by 2 को आप बाहर निकाल सकते हैं, that hardly matters. 1 by 2 is a constant. Convergence of t. Now you see, this implies nothing, but this implies that the series, so this means, just a color change, so this implies this summation tj is convergent if and only if summation log of 1 plus tj is convergent. But if you remember the definition of convergence of infinite product, then the convergence of this series log 1 plus tj implies that this product 1 plus tj is convergent. So you do not have to deal with this log series when you are having the terms of the infinite product tj's to be greater than or equal to 0. Is it okay? Or you have anything to say about it? You don't have anything? Okay then. So you by using this result, you can establish the convergence of the following. Establish the convergence of the following infinite product. Case product k from 1 to infinity 1 plus 1 upon k to power alpha. ओके तो यू सी हियर आपके पास जो 1 प्लस टर्म है तो दैट इज टी जेज का जो काम कर रहा है दैट इज 1/k अल्फा. नाउ सी दैट 1/k to power alpha is always greater than or equal to 0. So then what that implies, that 1 plus k to power alpha, this product is convergent whenever this series 1/k to power alpha is convergent. There is a test known as, जिसको आप usually अपने real answers में p test बोलते हैं, but you know that in case of p test this series summation 1/k to power alpha is convergent only for the choice of alpha greater than 1, and for alpha less than or equal to 1 it is divergent. Hence it implies that uh, this product 1/k to power alpha is convergent for alpha greater than 1 and is divergent for k less than or equal to 1, sorry, alpha less than or equal to 1. So this is the way you directly apply this result to check whether the given product is convergent or not. Is it okay? Do you have anything to say? Any doubt? By the way, let me ask once again whether you are getting my voice or not.
Yes, sir.
Okay, that's good. So let me now go to the another idea of the convergence of this infinite product, that is the absolute convergence of infinite product. Absolute convergence of the infinite product. So we usually now we say that the infinite product 1 plus aj, क्योंकि प्रोडक्ट की फॉर्म अभी में हम यही दे रहे हैं 1 plus j की फॉर्म में, it's absolutely convergent is absolutely convergent if we have the following situations, that this limit of aj needs to go to 0 as j tends to infinity, and another thing is that this series of logs, principal log of 1 plus aj, is a series, must be is absolutely convergent. So absolute convergence of infinite product comes from the absolute convergence of the series. Is absolutely convergent, but we have to be again careful that where we sum our those terms जहाँ पर log आपका डिफाइन होना चाहिए और log आपका डिफाइंड होगा अगर aj not equal to -1 होगा, where terms for which aj is not equal to -1, because aj equal to -1 के लिए you are not going to log to be a defined quantity. So this is the absolute convergence. That means आपके पास जो series convergence of infinite product के लिए convergent होनी चाहिए थी, अब अगर वो absolutely convergent है तो आपका product भी absolutely convergence है. तो first thing that you can see that you might have to observe is that absolute convergence in the way it happens in absolute convergence implies the convergence. ठीक है, यू कैन सी दिस थिंग, क्योंकि आपकी सीरीज एब्सोल्युटली कन्वर्जेंट है तो ऑब्वियसली ये कन्वर्जेंट भी होगी, तो हेंस योर प्रोडक्ट विल बी कन्वर्जेंट इफ इट इज एब्सोल्युटली कन्वर्जेंट. So the other way, it is not going to be true, as we will see some of the examples later on. And let me close up this with another result on the convergence of infinite product. It says that the infinite product, summation 1 plus aj, j running from 1 to infinity, converges absolutely, converges absolutely if and only if summation, the series aj converges absolutely, converges absolutely. And this series converges absolutely. This occurs if and only if the infinite product 1 plus mod of aj, j from, let's take the range also of j from 1 to infinity, is convergent. Yeah, this is it. So this is the absolute convergence card. This is a necessary and sufficient condition. And see, you don't have to establish the absolute convergence of an infinite product. You don't have to establish the absolute convergence of the log of this series of a log of these numbers. It's only the series. So this is a beautiful result, and it reduces your burden of dealing with the log function, which sometimes is not good to deal or good to understand also. But you see, first, uh, by definition, we know that this infinite product aj converges absolutely. I'm going to abbreviate absolutely with abs, if and only if we know this, that this series log एब्सोल्यूट कन्वर्जेंस होनी चाहिए. तो एब्सोल्यूट मीन्स आपका एब्सोल्यूट वैल्यू उसकी कन्वर्जेंस होगी log of 1 plus aj is convergent. Observe this thing. Now we have to deal with the log function. Now let us look at the log function. Log of 1 plus z, indeed not log, since log of 1 plus z is analytic at z equal to 0. This is analytic because इसमें negative excess नहीं आ रहा है जी अभी, ठीक है. It is 1 plus something, and so if it is analytic, it will have this power series expansion, and so it has power series expansion. That power series expansion can be briefly written as log of 1 plus z. It will first term इसकी z होगी plus other term जो भी होंगी z square z cube जो भी होंगी, तब तो we can write them as to be big O z square. You just read it as big O. Okay. So big O z square means all other terms will have z square as a one of the factor. So आप इसको लिख सकते हैं, ठीक है. This is a big O z, and this is valid near zero. When we say that this is valid near zero, I'm not going into detailing क्योंकि ये understood है. Near zero means in some neighborhood of zero, and which you can make that neighborhood to be as small as possible just to fit your idea. And now from here we see that क्योंकि बाकी जो terms हैं, they are this big O z square means all other terms are bounded terms of z square. The big O z का मतलब, let me explain this also. But you just keep it in mind. You don't need to, if you're not comfortable. We have two functions, f, and we have another function g. If I write function f as big O g, that simply means that f of x, yeah, f of z upon g of x is bounded quantity. And that will simply imply that each term fx is less than or equal to some constant times g of x. That's the way. That's not exact, but it's the way when you have these numbers in a neighborhood of 0. So this is it. So that simply means because everything here is bounded by z square. So from here, from this power series, we see that log 1 plus aj, its mod, is comparable with mod aj. अगर z को आप aj से रिप्लेस करें तो these two terms are compare because everything other is a bounded quantity, उसमें कोई है नहीं है, ठीक है. It's almost comparable when we, क्योंकि when you come closer to zero तो z square will come faster to zero, तो उसमें कोई उसका रोल नहीं होगा. तो so when we say that these two terms are comparable तो इनकी corresponding series की convergence भी if and only if में होगी. तो that means as a consequently the series taking the mod of 1 plus aj is convergent if and only if the series of mod of aj is convergent. So that establishes that, hence it implies that this product 1 plus aj is absolutely convergent if and only if the series summation mod aj is convergent. Now you see summation aj is convergent, and you see that mod of aj's are positive numbers, and as seen in the previous result, it implies that because these are tj's, you can replace tj's with aj's there in the previous result. That implies that this product log of 1 plus mod aj, not log, we don't need log there. This is product 1 plus mod of aj is convergent. So you have this equality. So you have two results equivalent to say. That means you have this 1 plus, you can say that 1 plus aj is absolutely convergent if and only if this product 1 plus mod aj is convergent. Yeah, that's all we have. So if you have any questions, any query relating to it, kindly you can ask me. Do you have any queries? कोई है कुछ?